Uranus is a planet full of surprises. It's an ice giant far out in the cold depths of our solar system. Unlike the rocky planets closer to the Sun, Uranus is composed mainly of hydrogen, helium, and methane, giving it that distinctive blue color. Unlike any other planet we know, Uranus spins on its side. This unique axial tilt of about 98 degrees means that it essentially rolls around the Sun like a barrel. Imagine a world where the Sun barely rises above the horizon for decades. This extreme tilt results in one of the most unusual seasonal cycles in the solar system. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. This strange tilt makes Uranus one of the most fascinating and mysterious planets to study. Its rings and moons add to the intrigue, each with their own unique characteristics and mysteries. What caused this unusual tilt? Scientists believe that a massive collision with an Earth-sized object billions of years ago could have knocked Uranus onto its side. How does this affect its seasons and weather? The extreme axial tilt leads to extreme weather patterns with powerful winds and massive storms that can last for years. Join me as we journey to this distant and enigmatic world to uncover the secrets of Uranus, the sideways planet. From its unique rotation to its mysterious weather patterns, there's so much to explore and understand about this ice giant. Let's dive into the wonders of Uranus and unravel the mysteries that make it one of the most captivating planets in our solar system. Uranus is much bigger than our Earth. To put it into perspective, if Earth were the size of a nickel, Uranus would be about as big as a basketball. This immense size difference is truly staggering when you think about it. In fact, you could fit 63 Earths inside it. Imagine stacking Earths like marbles inside a giant jar and you get a sense of just how vast Uranus really is. But despite its size, Uranus is not as massive as you might think. This is because its composition is quite different from that of Earth or even the gas giants like Jupiter and Saturn. This is because it's mostly made up of ices. When we say ices, we're not just talking about the kind you find in your freezer. Think water ice, but also methane and ammonia, which exist in solid form due to the extremely low temperatures on Uranus. These ices make up a significant portion of the planet's mass, all mixed with a swirling atmosphere of hydrogen and helium. This gaseous envelope gives Uranus its characteristic blue-green color, a result of methane absorbing red light and reflecting blue. Uranus takes a whopping 84 Earth years to orbit the Sun. That's nearly a human lifetime for just one trip around our star. That's like celebrating your birthday only once every time Uranus completes an orbit. Imagine waiting 84 years for your next birthday cake. This long journey around the Sun keeps Uranus incredibly cold and shrouded in perpetual twilight. The planet's tilted axis means that each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness, creating an extreme environment unlike any other in our solar system. The most striking feature of Uranus is its extreme tilt. While other planets spin like tops, Uranus is more like a ball rolling on its side. This means its axis of rotation is tilted at an angle of 98 degrees. This unusual orientation has puzzled astronomers for centuries. The leading theory is that early in the solar system's history, a massive object, perhaps even another planet, collided with Uranus. This cosmic crash knocked Uranus onto its side. This dramatic event is thought to be responsible for the planet's unique and intriguing characteristics. Uranus holds the record for the coldest planet in our solar system. The average temperature in its upper atmosphere can plummet to a frigid -224 degrees Celsius. That's even colder than Neptune, which is farther away from the Sun. This extreme cold is partly due to its distance from the Sun, but there's more to it. Uranus has a sluggish internal heat source, meaning it radiates very little heat from its core. This makes Uranus a truly icy giant, with temperatures that would freeze anything in an instant. Uranus might seem calm and serene from a distance, but its atmosphere tells a different story. It's a turbulent mix of hydrogen, helium, and methane ice. This icy methane gives Uranus its distinctive blue-green color. While Uranus doesn't have the same dramatic storms as Jupiter or Saturn, it does experience periodic storms and wind patterns. These storms can be surprisingly large and powerful, whipping around the planet at hundreds of kilometers per hour. Uranus, like its neighbor Saturn, has rings. However, they are faint and dark, making them difficult to see from Earth. These rings are composed of dust and small icy particles, likely remnants from collisions between its moons or comets. Scientists believe that these rings are relatively young and constantly changing. The gravitational forces from Uranus and its moons shepherd these particles into thin, distinct rings. Their dark composition suggests they contain organic molecules, making them an intriguing subject for further study. Uranus has a large family of 27 known moons. Unlike other planets whose moons are named after figures from Greek mythology, Uranus's moons get their names from the works of William Shakespeare and Alexander Pope. One of the most fascinating moons is Miranda. It has a chaotic surface with deep canyons, icy cliffs, and strange grooved features. This suggests a violent past, possibly involving multiple impacts and geological upheavals. Other notable moons include Ariel, Umbriel, Titania, and Oberon, each with its unique features and mysteries. Landing on Uranus would be no easy feat. Unlike rocky planets like Mars, Uranus doesn't have a solid surface to land on. Instead, it transitions gradually from a gaseous atmosphere into a slushy, icy interior. Any spacecraft attempting to descend through its atmosphere would face crushing pressures, extreme temperatures, and a turbulent mix of icy materials. A mission to Uranus would require incredibly robust technology and a deep understanding of this planet's unique environment. Uranus remains one of the least explored planets in our solar system. Despite being the third largest planet by diameter, it has largely remained a mystery to us. This distant icy giant orbits the Sun at a staggering distance of about 1.8 billion miles, making it a challenging target for exploration. Voyager 2, which flew past Uranus in 1986, provided us with our closest look at this icy giant. The spacecraft captured stunning images and gathered valuable data, revealing a planet with a unique blue-green hue caused by the methane in its atmosphere. However, this brief encounter only scratched the surface of what Uranus has to offer. However, many questions remain unanswered. Scientists are particularly intrigued by Uranus's extreme axial tilt, which causes it to rotate on its side. This unusual orientation leads to extreme seasonal variations, with each pole getting around 42 years of continuous sunlight followed by 42 years of darkness. Future missions to Uranus could unlock the secrets of its unusual tilt, its internal structure, its faint rings, and the composition of its atmosphere. These missions could involve orbiters, landers, or even atmospheric probes designed to dive into the planet's thick icy clouds. The composition of Uranus's atmosphere is of particular interest. It is primarily made up of hydrogen and helium with trace amounts of methane, water, ammonia, and other hydrocarbons. Understanding the atmospheric dynamics and weather patterns on Uranus could provide insights into the behavior of other ice giants in our solar system and beyond. Studying Uranus could provide valuable insights into the formation of ice giants and planetary systems beyond our own. By comparing Uranus with its neighbor Neptune, scientists hope to learn more about the processes that shape these distant worlds. Additionally, Uranus's numerous moons, each with its own unique characteristics, offer a treasure trove of information waiting to be uncovered. Uranus, with its icy beauty and enigmatic nature, beckons us to explore its mysteries and unravel the secrets it holds. Its serene, pale blue appearance belies the dynamic and complex processes occurring beneath its clouds. From its magnetic field, which is oddly tilted and offset from the planet's center, to its potential subsurface oceans, Uranus is a world of contrasts and surprises. As we continue to explore our cosmic neighborhood, Uranus serves as a reminder of the vastness of the universe and the endless wonders waiting to be discovered. Each new mission, each new piece of data brings us one step closer to understanding not just Uranus, but the broader mechanisms that govern planetary formation and evolution. The journey to unlock the secrets of Uranus is just beginning, and the potential for discovery is boundless. Don't forget to like, subscribe, and hit the notification bell so you never miss an episode of our solar system explained. Stay curious, and see you next time.